So we are learning Stream API, and we are right now learning pretty much like how the data that we have through the stream pipeline, how they will be flowing. But right now we are not pretty much involving threads and parallel programming and multi-threading and all those concepts, right? Right now our data are getting processed sequentially. Right now, basically we have one thread which is basically taking care of everything that we are writing in our code. And we are not caring about multi-threading scenarios right now or the parallel programming scenarios right now. But right now, whenever I start talking about it, even if there are a few developers who hate multi-threading, they'll be like, okay, Vilas, hold on. Just tell me how stream works. I don't want to learn about that parallel processing and parallel streams and those stuff because that will be too hard. I hate multi-threading. And obviously, if you're going to ask, around 70-75% of the developers will say they don't like multi-threading. And that's true, right? Even I don't like multi-threading that much, to be honest, right? I know a little bit of stuff like whatever I work with in my day-to-day project, but going through multi-threading, learning different stuff, it's like a sea. It's like, the more you learn, the new things you're going to keep on discovering. So multi-threading is a huge thing. And the developer hates multi-threading because it takes a lot of things time to learn threading, different concepts of threading. There are a lot of new stuffs there, and it takes a huge learning curve, right? And while you are coding with multi-threading, also you have to take care of a lot of different things, right? So learning multi-threading is not that much easy. Even I'm not sure if you're hearing this, Katie right now, how much of you are pretty much solid in multi-threading. Okay. So whenever I started speaking about we're going to be learning parallel programming right now with Stream, how basically we can process our streams or the elements that we have in the stream parallelly. When I start talking about it, even you are like, okay, well, let's just skip this topic, but hold on. Let me tell you, if you want to process the data that you have in a stream pipeline parallelly, right? So for an example, if you have data flowing in your stream, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if you want to process 1, 2, 3, 4, 5 and 6, 7, 8, 9, 10 parallelly through a pipeline, then you don't have to learn multi-threading so much. You just have to learn one method that the stream developer has given you. And everything else has been taken care of by the Java developer themselves, because they have created the Stream API keeping the parallel programming in mind. Okay, they have taken care of the threading stuff by themselves. So you don't have to do much of the things. It's going to be a cakewalk for you if you know a little bit how basically the things works internally, what Java API does behind the scene whenever it comes to Stream API. If you know a little bit about that thing, you are done. Like how the parallel stream works. That's what I'm going to explain you right now. Little bit. Let's just jump into the parallel stream, parallel stream concepts and how basically the parallel stream works. And later on, we're going to go depth into it. But right now, let's just start. Fresh. Like, what is this parallel stream? So guys, imagine like this is my computer and this is my CPU that I have in my computer, and I have a 1-core processor, 1-core CPU over here. And imagine I have one worker over here. Treat 1 core means one worker or one labor which will do the task for you. Okay, this is one person sitting over here in my computer, and he is responsible to do all different sort of works that I'm doing in my computer. A little bit of fundamentals. Let me first tell you right now, and then we will go into the parallel stream. Okay. So imagine I have 1-core CPU that I have over here, and here imagine I have a multiple task that I'm doing in my computer, like thread 1 or the task 1, or I'm hearing some music in my system right now. There's a particular task that I'm doing. So one thread is created in my system, which is basically taking care of listening to the music operation. Okay, let's say there is another thread over here, and this thread is taking care of my coding stuff. Let's say I'm right now sitting and coding something out in my computer. So there is another thread which basically takes care of that coding thing. Let's say I'm opening my editor and typing my code over here. Okay, so let's say I'm doing a couple of things right now. I'm hearing music and I'm doing coding, right? Two things I'm doing simultaneously. Then what do you think? Like how basically this couple of things getting into action whenever I have a one core CPU? Do you think all these two things that I have is running simultaneously? Because for me it's pretty simple, right? I'm hearing the music, I'm writing the code. So do you actually think that these two things are running parallelly in your system? What I mean by parallel, okay, that might sound a little bit of confusion, but let me tell you this first. So first, let's say sometime the music application is running, sometime the coding app also will run. Let's say sometime if I'm coding with Eclipse, that is running. Sometime my music player, my iMusic or iTunes is running. Okay, so sometime iTunes is running, sometime my Notepad is running, sometime iTunes, sometime Notepad. Like that, you know, one task is happening, then it's just getting paused, then the another task is happening, then again it is getting paused, then other task is happening, and again that is getting paused and the other task is happening. So it's just work, it's not running parallelly, but there are two threads over here. The way it works is like this. Let's say thread 1 works for some time, then it sits idle, then the thread 2 works, then again let's say thread 2 goes in a pause, then there is a switching happens, then the thread 1 basically working. Okay, let's say the music stuff is working, and again let's say thread 1 is going for a pause, and then the thread 2 starts working. So it's the thread 1 and thread 2 are not working parallelly, right? They are working interchangeably. So when the thread 1 is working, the thread 2 goes in ideal state, and when the thread 2 is working, the thread 1 goes in ideal state. And this is going so fast that as an end user, we are not noticing any lag or something. For us, everything is working parallelly, everything is working together, but in reality, that's not happening, right? It's just like it just switches, and it switches very fast, so that the end user like us, we are not able to notice. That's why if I have a one core CPU and if I have thousands of tasks running, then my system starts lagging, and I as an end user start noticing those slowness in my computer. I think you understand the concept of here. Now imagine what I have over here is this. The thread 1 works, then the thread 2. Then the thread 2 goes in ideal, then the thread 1 works. Then the thread 1 works, then the thread 1 goes into ideal states, then let's say the thread 2 works, right? So it's like switching between one thread to another, one thread to another. But what actually I want my task 1 and task 2 to be performed parallelly like this, so that my task can happen really faster. I can go really fast with my computer if couple of tasks are happening or gets performed parallelly, right? That's what I need. So right now, imagine if I have multi-core CPU, my CPU has 3 core, 6 core, 8 core, 12 core, right? So if you have very fast MacBook Pro like this, let's say if I have a MacBook Pro laptop, then I have 6 core, even I have 12 core CPU, right? So imagine I have a CPU like this, and I have right now 4 cores available here. Let's say core 1, core 2, core 3, core 4. If I have 4 core CPU over here or 4 core processor over here, you can treat them like 4 different workers. Okay, so all these 4 workers right now can work simultaneously. Let's say I will give some tasks to core 1, I give some tasks to core 2, then core 3, then core 4. Okay, now one task I have assigned to each core. Now all these 4 guys that I have right now, they are like 4 workers that can work simultaneously, right? They can work in parallel. Let's say if I have thread 1, thread 2, thread 3, thread 4, they all can work parallelly like this. So if I have one worker who is doing all these 4 things, then obviously that will take time. But if I have right now 4 workers working on each of the tasks that I told them to do right now, then I can go really fast. Okay, so this is what parallel programming means, right? doing stops parallelly in simple term, right? Okay, now let's just see this. Imagine I have a 4-core CPU like this, and there are 4 workers like this, and there are 4 threads. Let's say I know I can assign them 4 tasks together, and all the 4 tasks can run simultaneously. Now imagine if I have a stream pipeline like this. I have a stream of, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 elements that I have on the stream, and I have a filter method, and I have a map method. Okay, and I have a forEach method over here. So far we're writing programs like this, right? So what basically happened, let's say if I write program like this in my MacBook Pro that I'm using right now, which has around 6 to 12 cores, I think I have around 12 processors available in my system right now. 12, I think around 6 or 12 cores are available right now. I think 6 physical core and 12 logical core. Let's not go into physical and logical right now. Imagine my system right now have 12 different cores available. So now you think like, if I have 12 core machine, if I write program like this, what is going to happen actually? All these elements right now will be given to one core. Okay, one core will take that data and try to process my data, right? So one thread, basically this task, imagine this task is, the task of this thread is to process the data of this, right? So basically this thread is responsible to processing this data. Now imagine I have only 10 elements over here, but let's say I have millions of elements. I have thousands or tons of elements over here. Then what will happen? Then obviously, even though I have a 12 core machine, still only one core is basically taking care of processing all the millions of data that I have. This thread is only responsible. That's the only thread which is basically taking care of processing that millions of data. Where all these other cores that I have, they're just sitting ideally and relaxing. I don't want that. I haven't spent my money to purchase this laptop to do that kind of things, right? I don't want my core to be sit ideal and relax. I just want to give them work, right? So with parallel stream, what you can do, this stream is not a parallel stream, it's a sequential stream, right? So only one thread is doing the work of this particular guy. But if I go parallelly, I can just do one thing. I can just do this dot parallel, and that's it, guys. Now all my core will come into action and start processing my elements that I have over here parallelly. So you don't have to learn multi-threading, how the thing that we are discussing, how we can actually implement in real time. You don't have to do that. The dot parallel method will do everything behind the scene for you. And the data that you have over here, they will all go parallel, and they all will be processed parallelly. Okay, maybe this raised to a little bit of confusion. Okay, tell me how it will be processed parallelly. Imagine I have few elements 1, 2, 3, 4, 5, 6 up to 10. Imagine to the thread 1 right now, 1 and 2 elements I'm giving it to thread 1. Okay, let's say there are other elements over here. Let's say 5 and 6 I'm giving to thread the task 2 to the core 2 worker. Let's say 7, 8, 10 I've given this data to, let's say, core 4 thread. Okay, and let's say 3 and 4 I'm giving it to thread that is basically available inside the core 3. Now I have splitted my elements in chunks and giving it to multiple threads. Okay, now what will happen? Now all these 4 threads that I have, they will right now, okay, they will work together, but to work together, obviously they need all this method, right, that I have. Imagine there is a copy of this kind of method that I have for available for each threads right now. I have, let's say I'm doing something filtering, then doing something mapping. Okay, then all these methods that I have, right, they are all copied over here. Imagine there is a copy of them is available or something like that for each thread to process these elements. And now what will happen, guys? All this thread is going to work parallelly. Okay, and all this thread will basically process those elements parallelly, and now I can collect them using the forEach method and then get a result. Okay, and then get a result. Okay, so basically the thing is over here, the elements that I have, the most important thing that you have to understand over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all these elements that I have, they all will be processed parallelly by different threads that I have, and none of my threads right now sitting and relaxing. They all are working with some data and trying to process it. Okay, so this is what parallel stream means, where we are processing data in chunks, where we are first splitting this data in a try and split method. There is some methods like try and split method, where we are basically creating chunks of data, right? My data I'm splitting into in chunks, right? Then I'm actually creating multiple threads. And how many threads will be created? Let's say my system is four core, then 4 threads will be created. Let's say my system will be 12 core, then 12 threads will be created. Everything will be happen automatically by that parallel method that I have, right? So that will basically create number of threads. And to create all these threads and to split this data and obviously to join the data after processing, right? So that's what you're doing, right? First it is splitting the data, then it is processing the data, then it's once the data has been processed, again it is joining everything and giving you the result. Now to do that, basically Java internally uses a framework called fork and join framework that basically came in Java 7. So that's what I said, like, to learn parallel stream, you don't have to understand how multi-threading works, how fork and join works, how completable future works, or how future API works. You don't have to learn anything. Just learn that parallel. And all these things happen behind the scene, right? Previously, imagine if you have many cores, like 4 cores I have, only one thread was there, which is main thread, which is by default created in every Java application. That is the thread which was taking care of processing my data. But right now, with the help of this parallel stream, if I'm going to use that dot parallel method over a stream object, all my threads will work parallelly. And each element that I have over here will be given to each of this thread, and this thread will be processing those data parallelly right now, and things will happen all together, right? That's the beauty right now that we're going to be seeing right now. Okay, so just remember one more thing, just for clarity. I told you, like, every core will have one thread, and all these threads will be right now processing data just like this parallelly. All the 4 threads will be running. So right now you might have a question that, can I have other threads associated with one core? Let's say, can I create one more thread which will be taken care of the core 1? One more thread can I create for core 2? One more thread can I create for core 3? One more thread can I create for core 4? Now each of my core has two threads like this, right? But you might have question like, can I create more than 1 threads per one core? And all answer is yes, you can actually create. There is nothing to deal with Stream API right now. I'm just telling you, just in case if you have any doubts or question. So you can actually create multiple threads for one core. But just remember that if one thread is working right now, the other thread need to sit idle. But if this thread is working again, this thread will sit idle, right? So for each of this core, for this core, only one thread can work at a time. Okay, for this core only one thread can work at a time. Okay, like that, if I have 12 cores, 12 threads can work at a time, but the other threads can wait, and then like the context switching and the way they works, right? That's it. All right, so let's just get started where we right now. We're going to be having some practical walkthrough, and we're going to see the parallel stream in action. So I took a little bit of break. I went to play carom, and yeah, so I don't know, like, even I didn't set my hairs or anything, I just came straight away like this. So I don't know. Yeah, so excuse me if there is any powders or anything in my hand. I think it's all clean. All right, so we can get straight away to action right now, and we can start learning the parallel stream, and we're going to be learning, like, how we can process the data parallelly over here. So you can see right now the time is 11:04. Okay, and I'm gonna teach you something about how to process data parallelly with stream. And the reason why I'm so confident, and even I didn't have any preparation, because I know it's very simple to show you how the parallel stream works. I don't have to make you understand about multi-threading and the other stuff right over here, because everything's has been taken care already by the Stream API developers. You don't have to do a lot of things over here in order to process data parallelly over here. As I said, it's pretty simple. Let's just get into it. So you'll see, like, how simple is it right now. So first of all, so let's say we have a get student list, which basically returns a list of student, and there goes some student data. There are actually 13 students available, and each student carries an ID, the name of the student, the phone number, and the age, right? So I have created a bunch of students here, created a list over here, added all the students over here, and returning this list that I have created over here right here. So this method, getStudentList, basically going to return me a list of students. So what I want to do over here right now, I'm going to be calling that method and going to be processing those students right now. So let's say the way I'll be calling the stream out of that particular list that I have. First of all, I'll be calling that list over here and we'll be creating a stream out of it. And then let's say I want to process each data that I have on the stream. I can basically take a student object and I can print it out, as you guys know, right? So it's as simple as that. And right here, as I said, the data will be sequentially processed. There is no threading, multi-threading, parallel processing, nothing has been involved over here. It's pretty much straightforward as this. So you can see right now we have this source. Imagine this is our list of students, and we have each students over here, which is going to be processed by our core. Imagine right now we are not utilizing the core that I have in my machine. I'm doing this type of processing right now. Okay, if you can see this example, I have data like 1, 2, 3, 4, 5, 6, 7, 8, 9. Everything, the processing of this data has been taken care by one thread, by one core. Okay, but if you're going to see this one, this is actually the parallel processing. Here 1, 2, 3, 4, 5, 6, 7, 8, 9 are all getting processed parallelly. The core 1 is taking care of these 3 elements. The core 2 has taken care of these 2 elements. The core 3 is taking care of these 3 elements and is parallelly processing these elements. But right now, here means sequentially the data will be processed, right? Everything that I have on this stream will be processed by this core 1. Okay, so it's like 3 person are basically processing this data that you have. Here is 1 person is processing every elements that you have on the stream. It's something like that. Right now, if you're going to go back to my IntelliJ, so it's like everything that I have in this stream is getting processed by my, thread, which is the main thread. Whenever the Java application starts, by default, a thread is getting created, what we call main thread. So that's the only thread that I have. So even though I have this MacBook Pro with me, which has around 12 core, I'm not utilizing the 11 core over here. I'm just utilizing 1 core that I have, and 1 thread is basically taking care of everything that I have over here. It's processing each of my students over here. Okay, so it's a sequential stream example, the data processing example. And just to understand, like, how much time it is taking to process this data, what I'm going to do, let's just call the system dot get let's say current time in millis. So this is going to get me the current time right now. I'm going to handle the return type. I just want to check, like, to process all the student and to print it out, how much time this sequential stream is taking over here. And I'm going to say end time here. Okay, and let me just put it like this. Okay, it's more readable. That's it. So right now I'm gonna do a s out, and I'm gonna say time taken by sequential stream is, and I'm gonna do plus end time minus start time, and I'm gonna be wrapping it off with a brace like this, and I'm going to be ending my sysout over here. Okay, so if I'm going to be running this, obviously it is going to print all of my students, and then I'm going to see how much time it is taken to print all the students. So you can see these are all my students that I have on the stream right now, and the total time it has taken is 28 milliseconds. Okay, now let's just try to do the exact same thing. Now I'm going to copy this, Control C and Control V over here, and I'm going to have a separator over here right now just to separate these lines of code. Now here what I want to do, here also I want to process all the students that I have, but I want to parallelly process each student, right? So right now what I'm going to do, I'm going to do get student dot stream, and I'm going to do dot parallel. Okay, and now what I'm going to do, I'm going to say start time 1, end time 1, and I'm going to be doing a minus of end time 1 and start time 1, and I'm going to be checking how much time it takes. So if I'm going to run this, okay, first let's say right now this is the result of my sequential stream, and this is the result of my parallel stream. Okay, for the sequential stream, you can see the time which has been taken is 24 milliseconds, and it is like 8 times faster. The parallel stream is 8 times faster. You can see it is only taking 3 milliseconds. Well, it is still saying sequential stream. Maybe I have to change this to parallel. Let me copy this. Let's say time taken by parallel stream is this. So let me run this again. Okay, so you can see right now it is taking 20 milliseconds, the sequential one, but this one is taking 4 milliseconds. So as I said, in sequential stream, all the students will be processed by only one thread, which is by default created by Java. But when it comes to parallel stream, all the student elements will be processed by different core, which is available in my CPU, right? So multiple threads will be involved right now to process all this data right now for me. I want to prove that for you. See, you don't need to understand how it is happening internally, to create a parallel stream. As you can see, how simple is that? Okay, even though you want to do any operation, it will be pretty much straightforward. You don't need to understand how everything is happening. But I just want to tell you what is happening in the background, right? For an example, guys, let's say as a noob right now, I want to apply some filtering. Okay, this is my sequential stream, right? I'm just calling the stream method, and I'm going for forEach. Let's say I'm just doing some filtering. It's pretty simple in the sequential stream. Let's say I want to filter every object that I have, and I want to filter based on based on the age. Okay, let's say just return if the student dot get age is greater than 25. Okay, I'm doing it in my sequential stream. Okay, but if I'm going to come to the parallel stream, it is going to be exactly same as that. You don't have to do anything special. Similar filter, you can also put it over here. You can come to the parallel, just do a dot, or put it like this. Okay, exactly same code. You just need to make sure you're writing this parallel in order to make this parallel processing works. Right now also, if you're going to run this, you're going to be seeing the exact similar result. You can see this data has been processed in 19 seconds, the sequential data, but the parallelly, whenever we're doing it, we are doing it in 4 milliseconds. Okay, so and one difference that you can see right now over here, guys, when you check the sequential stream, you can see the insertion order is preserved. For an example, if you're going to come over here, this is the way I have inserted all my data. First Jareen, then Avilas, then Jatin, then Rakesh, then Soumik, then Priya, then Lavanya, then whatever. And you can see the data that I have in the sequential stream is exactly in the same way. Jareen, then Avilash, see? Jareen, then Avilash, then Rakesh. I think Jatin has been filtered out because of the condition. Then let's say Rakesh I have, then let's say Soumik I have. Everything is in the way that I have inserted, in the same way it is printing. But if you want to see the the other stream that I've created, the parallel one, here the data are not in sync. You can see Here the data are in like, just follows the insertion order because the data processed one by one in the stream. But here what happened in the parallel stream, as I said, my CPU have multiple core right now. Okay, let's say my CPU has around how many cores that I have on my CPU. Let's say assume my CPU has around 14 cores or 8 cores or 10 cores, right? So 10 cores means every core will create one thread by default. All of my students will be assigned to one thread. Let's say Kiran will be assigned to some thread, Divya will be assigned to some thread, Krishna will be assigned to some thread, Priya will be assigned to some thread. So every threads are processing their respective data together, and the thread which is faster, it is printing its data first. Right now this data Kiran here is printed first because the thread which is handling this Kiran object is fast enough to print the data first. But here everything is going sequentially. So sequentially we are getting the data. But here there is no guarantee because multiple threads are involved. So the thread which is faster, it is first printing the data for me. Okay. So here only one thread is involved, and here many threads are involved, right? Let me just prove you that first. Okay. First of all, how many in my parallel stream, I told you here many threads will be involved over here. So how many threads will be involved over here by default? So how many core my MacBook has right now? So let's just taste it. Okay. So I'm going to comment out everything for a minute. Okay. I'm going to comment everything. Okay. And over here, let's just try to see how many cores that I have. I'm going to sys out. I'm going to say runtime dot get runtime dot available processors. Okay. Let's just check how many processors that I have, right? And I have around 12 processors. Okay. That means by default, I have 12 cores available. So right now, what a Java will do, it will create 12 threads for me. Okay. So I have 12 core. Every core will be having one thread, and they all will be processing my data parallelly. So in a parallel stream environment, something like this, whenever I'm doing this code, let's say whenever I am acting upon this get student list and creating a parallel stream over here, let's say how many students that I have. I have 13 students. So around 12 students will be handled by 12 different threads, and maybe one of the thread is handling around a couple of students. Okay. And they're processing the data together. That's why it is just getting done in pretty much faster when we compare it to the sequential stream. I think you understand that. I just want to show you that practically. So what I'm going to do for an example, let's just comment out, let's just remove this code, the sequential code right now. Let's just come to this part. Okay. Let's just think like I have a very normal sequential stream. Even I just want to remove this couple of line, don't want to have more traffic over here. Just want to, have some clear, understandable code over here. Now, I just want to know like which thread is basically processing my student, right? So let's just do that. I'm going to have a sout over here, and I want to just check the thread which is processing the student, right? So let's say it's a filter log, and I'm going to say applying a filter on student, and I'm going to be printing the student name, by the way. So I'm going to say student.getStudentName. I'm going to be printing the student. So applying the filter on the student, and I also want to print it has been processed by which thread. Let's say student processed by thread. Okay, I want to print the thread name as well, who is processing it. Okay, so how can I print the thread name? I'm gonna say thread dot current thread dot get name. Okay, so now you can see right now if I'm gonna run this. Okay, let's just check. See right now, first this 12 is what? The number of processors. I just want to remove that as well. Okay, remove that. So I will just have some clean code over here. Perfect. So you can see first the filter is applied for the student Jareen. Okay, and it has been processed by whom? Main thread. Why? because it's a sequential stream. Okay, it's a stream. There is no parallel over here. It's a sequential stream. So obviously the main thread is the only thread that I have, and you can see Jareen has processed by the main thread. For processing Abhilash also, main thread is responsible. To process Jatin also, the main thread is responsible, right? So every operation that you do over here, main thread is only responsible. I can also show you that and prove you that. For an example, right now, I am also printing the student, the entire student detail over here. Let's say I just want to print the student name. Then how can I do that? For example, in the filter, it is returning the student whose age is greater than 25. Now what I want to do, I want to map over here the student object I will take, and I will only return the student name. I just want to print the student name only. So let's say I'm going to do map, and I'm going to take a student right now, and I am going to do this. I'm going to return what? I'm going to take the student, and I'm going to return the student.getName. Okay, that's it. And here also I'm going to print the student name only. Okay, student name and student name, right? Just changing the variable to, make sure it makes sense to you guys. If I'm going to run this, okay, it's printing the student name only, right? And every student that I am printing over here, it is being processed by the main thread. Okay, so you can see everything is main only, right? Not only the filter method. If you're going to keep some log over here as well, let's say I'm going to do copy. I'm going to come over here to the map and paste it as well. I'm going to have a log on the map as well, and I'm going to say applying map on student, and I'm going to just get the student name and processed by thread and this. And for the forEach also, I'm going to do the same thing. Okay, let's say I'm going to do wrap up this thing like this. Okay, and I'm going to end it over here, and I'm going to give a break here, give a break here, and I'm going to have another log over here, and this is my forEach, right? This is my forEach. And for applying the forEach on each student, and then I'm gonna print the student name is already coming over here, and is processed by which thread, right? If you're gonna run this, you can see the result. Okay, let's see, like everything is processed by main. You can see, let's say for a student Jareen right now, if I'm gonna put it over here, you can see the log. Okay, for this student, all my filter, map, forEach, everything has been done by the main thread only, right? Similarly, for another student, if I want to see Abhilash, the filter has been applied over here by the main thread. The map is also has been taken care by the main thread. The forEach also has been taken care by the main thread for the student Abhilash, right? So for every student has been processed by the main thread only, as you can see over here from the log, right? So this is how the main thread is only responsible when it comes to the sequential stream, as I said, because we are not utilizing the core. We have only one core, let's say the core one, and let's say by default the Java is creating a thread called main thread, and that is the guy who is responsible for everything. But when it comes to sequential stream, we can change how to create a sequential stream. As I said, you can either do parallel like this, okay, or you can also do this, I think, parallel stream, and either of the thing works. It basically creates a parallel stream. But I think as per the Java doc, this will not guarantee that a parallel stream will be created. Though the code works 100% correct and this creates the parallel stream, but the Java says, like, if you want the stream to be parallel, then use this parallel method. It will 100% gonna chunk your data and gonna be processing it in a chunk only, right? So in this case, what is going to happen? Okay, just think about it. I'm using parallel means right now multiple threads will be created. All of my code will be in action. So as I have a 12 core CPU, as per the print that we had previously, I'll have around 12 threads created. Every core will be having one thread, and all of the threads right now is going to be picking all my student data that I have, right? So if I'm going to run this, okay, if I'm going to run this like this, let's just analyze the data that we have. Okay, so yeah, the data are messy. The print statements are, like you can see, the filters first, and it's just a little messy. The data, the prints are happening not in a sequential way, but we'll find it out. Okay, let's just find this data Rakesh, right? So this is the filter for Rakesh. By whom this the Rakesh is taken care by whom? The worker 6. Maybe this is the thread name. Okay, so the fork and join pool, you can see the thread is getting created by the fork and join framework. So the name has given like this by Java. But yeah, the worker 6 is the guy who is handling this Rakesh data. Let me copy this control C. This is the filter log, and I'm gonna look like how the Rakesh data has been processed. I'm gonna put my log over here. It has been processed by the worker 6. Okay, cool. Now let's just find the other log for the Rakesh. Okay, can I do Control C, Control F on this? Look for the other print. Okay, here is a match. This is for the map. Okay, so print it over here. Put it over here. Okay, the map log right now you can see this has also been taken care by the worker 6. Okay, so the thread number 6 of the worker 6 is basically taken care of the Rakesh object, right? So you can see right now, I'll also find Rakesh object more. I just want to find the forEach. Again, you can copy this. You can come over here and print it out and look by whom this Rakesh object, the forEach method has been called by the worker 6 again. So the worker 6 has taken care of the Rakesh object. Okay, it processes it through the filter, processes it to the map, processes it through the forEach, just the way that I have told you over here. Okay, so every thread will have a copy of filter, map, and obviously I have written forEach over here, but you can think like the same thread is right now taking care of the forEach as well. Okay, so this is good. So let's just go back. Okay, so I understand about the Rakesh, then it's printing the data of Rakesh. Let's just pick some more data. Let's say Jarin data I want to pick, right? I'm going to do Control F on Jarin. Okay, let's just go to the top. Okay, this is the filter for Jarin. Control C. Let me just check like how this Jarin has been processed. It has been processed by the worker 11. Okay, so it has created around 11 or 12 workers, I feel. Okay, so 12 threads I told you, no? 12 threads right now are going to be created and will be involved in processing all this data, right? Because I have a 12 core CPU. Okay, so Jarin has been processed by this. The next log for Jarin is here, and this is also Jarin's log. This couple of things are Jarin's log, and you can see the Jarin K for the filter. It has been processed by the worker 11. Map also has been processed by worker 11. forEach is also has been processed by worker 11. So the worker 11 is taking care of the Jarin object, right? Like that, Priya object has been taken care by the worker 5. You can see this is the map log, this is the forEach log for Priya K, and it has been processed by the worker 5. Okay, so what we understand is that right now many threads are involved on processing our student data, and whatever we have seen in our slide, that is exactly what is happening over here. Okay, so you can see all of my CPU core are in action right now. They all are processing the data over here by using the fork and join framework behind the scene. Basically, it's processing all the data by different threads. Once the result they are getting, they're basically joining it up, throwing it to my console. That's why my console is not sequential. It's a little messy, but every data that I wanted over here is over here. My goal was like to process the student and to print it over here. I don't want this unnecessary log, by the way. These are all to show you. If I'm going to remove everything that I have over here, my goal was just to print all the student to the console. And if I'm going to do that, okay, that's what the data is. I don't care how that happens behind the scene, but I got my data in a pretty faster way because multiple threads are working upon it right now. All right, so now let me just brief you a little bit about a very important concept in parallel stream. And maybe this is the first thing that you should be aware before approaching any parallel stream development work. This is that important. Let me tell you what exactly I want to explain you. Okay. So imagine you have a list. Maybe I'm going to create a list of integer. Okay. I'm going to say list of integers, and I'm going to say new array list. And let's say a list of integers dot add, and I'm going to be adding off, let's say, few elements. Maybe I will be using a add-all method instead, and I'm going to add a bunch of element to this list. So I'm going to say list dot off, and maybe I'm going to say 1 2 3 4 5 6 7 8 9 10. Okay, I'm adding some bunch of elements to the list. Okay, now what I want to do, if I want to do list of integers, okay, dot stream, because I want to open up a stream. Okay, and then let's say I want to process this bunch of elements. So I'm going to say a dot forEach, and I'm going to say number that I have, and I'm going to print out every number that I have over here on the stream pipeline that I'm opening. Okay, it's pretty obvious that you know what is the result that I'm going to get. It's going to print out everything that I have on the stream. Okay, on the stream pipeline. Now I have a question for you. Now, is it a parallel stream or is a sequential stream? Well, how to check that? Is it a parallel stream or a sequential stream? You should be aware that whenever I use this method, this opens off a sequential stream for me, where the element will be processed by one by one single thread, where I'm using only one core of my CPU. But I'm using a very costly setup right now to produce these videos, and I have multiple cores. So I can open up a parallel stream pipeline in order to process all these elements using all of my cores of my CPU. That also I can do by using the dot parallel method if I want to process the stream in a parallel way. Okay, I can do dot parallel to open up a parallel stream pipeline. I told you that. Now, how to confirm whether a stream is parallel or sequential? Okay, so let's just do one thing. Right now, if I'm going to end off my statement over here, so this stream I'm opening off over a list of integers defined over here. So this is going to get me a stream of integer, and I'm going to say stream of integers. Okay, and now I can do this stream of integers dot forEach. Okay, and I can import this. Okay, now I'm using dot parallel, so all this element will be processed by multiple threads of my multiple core of my CPU. And you can see right now this is obvious that I'm getting an inconsistent output, but all my elements are getting processed. Okay, but as I'm using the dot forEach method, the forEach method doesn't guarantee that whenever you're using it with dot parallel, your sequence will be preserved over here. So let's say here it states that the 7 it prints first, because as you are opening up a parallel stream, and then multiple threads are involving processing all of my elements, and whatever elements has been processed first, the forEach is basically consuming that elements and prints it to your console. Okay, but let's come back to the main question right now. I want to check whether this is a parallel stream or a sequential stream. I know it's a parallel stream, but just to cross check, how can you do that? If you have a stream pipeline, you want to check whether that is parallel or sequential. You can do this. You can have a sysout, and you can take your stream pipeline, stream of integers, and you can just check by using this is parallel method that I have over here. Now, if I'm gonna run this, by the way, this is going to get me true because my stream is processed parallelly. I have used the dot parallel method. If I'm gonna remove this, as you know, if you want to use dot stream means by default it is going to be a sequential stream. Now you can see the insertion order is preserved because every element will be processed one by one element, one by one. The element will be processed inside this stream pipeline, and obviously whenever I check this is parallel, it gives me false. Okay, so you know about this. There is another method called dot sequential, just like your dot parallel. Okay, if you're going to use dot parallel, what it is going to return, you can see is going to return a stream of integer. So if anything returns you a stream of integer, that means that's a intermediate operation. Just like your parallel, you also have a dot sequential method, which also going to return a stream of integer in this case, because this sequential I'm applying over a stream method, and the stream is applied over a list of integers. And obviously if I'm going to apply dot stream, is going to return me a stream of integers right over here, the way I have written that over here. Now the important thing over here, I can use dot sequential over here if I want to convert a stream to a sequential stream. Okay, now here this is a sequential stream. If I'm going to run this, no obvious changes you will notice. You will see that your elements has been processed sequentially, and is parallel is giving you false over here, which is obvious because it's a sequential stream that I have mentioned over here. Now here is a very important question. Is it really necessary for me, if I want to create a sequential stream, should I use this method? Previously throughout this course we haven't even used this method ever to create a sequential stream. Okay, because whenever we use this dot stream method, by default it opens off a sequential stream. So there is no need of writing this dot sequential whenever you are dealing with a sequential stream. But I'll tell you where basically you can use it. Okay, imagine I'm gonna bring this down. Imagine I have a stream pipeline open over here, and I want to process all these elements in a parallel way. Okay, so I'm going to say dot parallel, and I'm going to tab it a little bit to this. Okay, now I have this dot parallel, and now I want to process all my elements parallelly, and then I have some kind of map operation going on. Let's say I'm going to take each number and I'm going to be multiplying that number with 2. Okay, let's say these operations will happen parallelly, or it's going to happen sequential, because I've written parallel over here. Okay, so do you think the entire stream pipeline is parallel? Because just because I have written parallel over here, the map I'm writing after this, so do you think the map, these operations will be also be performed parallelly by multiple CPU cores where multiple threads will be involved? Or as I'm writing this statement after dot parallel, this will be processed sequentially? What is your answer to that? Just remember this point. If you write dot parallel here or even dot parallel here, it's the same thing. Okay, what you are doing is you are converting the entire stream pipeline to a parallel stream. Okay, make sure you remember that. Okay, so if you're gonna do this, okay, and then dot filter, for an example, let's say I'm gonna do some more operations, and I'm gonna check if the number is greater or less than 500 or something, or 5,000 or something. Let's say I have some kind of operation over here, and I'm bringing the dot parallel to here. That means what do you understand over here? Or if I'm going to put dot parallel over here, okay, so do you think the map will be processed sequentially because this is a sequential stream, and this filter will be processed parallelly because I have written dot parallel over here? No, the entire stream is either sequential or parallel. Right now I'm using dot parallel, means it will be parallel only. So you can see this is parallel method for this stream of integer is going to give you true right now, and as you can see it's true, and you can see the elements has been picked randomly, and obviously we are transforming our elements over here. So maybe if you're gonna see 1, 1 into 2 will be 2. You can see 2 is over here. So the ordering is not guaranteed whenever you're using for each method to consume the stream, okay, the parallel stream. Okay, now I have another question. What if I'm going to do this, if I'm going to do dot filter, after that dot sequential? Now what is going to happen? Now this is a question for you. So what do you think? So the map thing will, otherwise if I'm going to do this, just to confuse you guys a little bit. Okay, let's say I have dot parallel here, okay, and then before using filter, I'm using dot sequential, okay, then what will happen? Okay, so your map will be processed parallelly, okay, because I have used dot parallel, and then your filter will be processed sequentially because I have used dot sequential over here, isn't it? And that's obviously a wrong conception. You can see now the is parallel is going to give you false here. Okay, why? Remember my words that I told you previously, my statement. The string pipeline will be either sequential or parallel. Here I have used dot sequential at last, right? So this parallel stream I'm converting to sequential stream again. Okay, so if I'm going to run this, your elements will be processed sequentially, and you can see the is parallel is false right now. Now see, the is parallel is giving you false over here because I have used dot sequential over here. So dot sequential you can use to convert a stream to a parallel stream to a sequential stream. Okay, so the stream can be either parallel or sequential, and after that, after doing this, if you can do dot parallel, then what is going to happen? Okay, now run this. Okay, see, now this is true again because the stream can be either parallel or sequential. Right now at last I'm doing dot parallel, that means I'm converting the stream again to true. And if you're gonna do dot sequential again, it's a intermediate operation, as I said, but end of the day what matters is either parallel or sequential. Okay, it's false. I hope this makes sense, and remember this, very important. Now let's just do one thing. Let me remove this sequential from here. Let me remove this parallel from here. Let's say my entire stream pipeline is a parallel pipeline that I have where my elements will be processed parallelly. And I'll remove this println, and this forEach I'm gonna merge it with my pipeline directly instead of using a new statement over here. I'm going to do this, and obviously this is going to return void. The forEach doesn't return anything, so I'm going to be removing that as well. Okay, so imagine this is what I have. Okay, now I have a question for you. So if I'm going to use forEach like this, then I told you one thing. This is a stream I'm opening up. I'm converting it to parallel. Then I'm doing all these operations parallelly. So multiple threads will be involved processing my elements. Maybe thread 1 will process this many, thread 2 will process this many, thread 3 will process this many, and it goes like that. And it's also it is obviously happens that if these elements are processed by thread 1, thread 1 might again split it into 2 more tasks. Maybe 1, 2 will be processed by another thread, 3 will be processed by another thread. Okay, internally the fork and join framework will be splitting this task into multiple subtasks, and the subtasks again can be split into multiple tasks again, and then somehow it is doing all these things behind the scene. We're not messing off with the fork and join framework the way it works, but we understand that this is how the thing works internally. I have one question over here. Okay. Now, if I'm using for each, the insertion order that I have for the list, I'm losing that insertion order. Okay. The ordering is not preserved whenever I'm using the for each. You can see now the first element to be processed is 1. If I'm going to perform this operation, the first element that I'm expecting in my console is 2, but the 2 is printed over here. Maybe because the 14 I'll get for what? Maybe if the number is 7, so 7 into 2, it will be 14. But I think this element is getting processed first, and that's why it is there on the console. But if I want to preserve my insertion order, maybe in some cases I might need that feature, then what I supposed to do? In that case, I'll be using the forEachOrdered in case instead of the forEach only. Okay, the forEachOrdered can be used in parallel stream if you want the ordering, if ordering is very important to you. Then if I'm going to run this, you can see I'm getting all my elements in a ordered fashion. Okay, so you can see right now 14 is here. Previously the 14 was in the first place. Okay, so here I am ordering the things, but does this means I'm losing the parallel stream feature? Am I not processing the elements parallelly? No, it's not like that. You need to understand this. The forEachOrdered is basically, obviously, from here your stream is becoming sequential. I'm only breaking my statement, right? I told you the stream can be either parallel or it should be sequential. But now I'm saying that the forEachOrdered is basically going to consume the things in a sequential way. But I'm also telling you that all these elements will be processed parallelly because I have used dot parallel. But what you have to remember here is that the forEachOrdered is a terminal operations. This is used for consuming the elements. Okay, so if you are using for each here, okay, you are basically using all of your cores throughout the stream pipeline, even for consuming the elements. Whenever you are gathering the elements, at that time also you are using all of your cores. So this will be processed by one thread, this will be processed by one thread, this will be processed by one thread, and this is also going to be processed by a thread, by a separate thread. And this can happen for each elements, considering that if every elements will be processed by one different cores, that if I have it available in my CPU, for an example. But what you have to understand is that if you are using for each with the parallel, that means whatever task has been executed first, the for each is going to consume that. Okay, but this is a terminal operation. Okay, but if you're using forEachOrdered, okay, that means your stream is still parallel. Okay, all these operations will happen parallelly, but the forEachOrdered is going to wait, okay, to make sure, to consume the elements in the same order the way it has been processed through the pipeline, right? But it is not taking away the feature of parallelism, unlike the other scenarios that I have shown you, right? So this is still a parallel stream, but the consuming is happening in a sequential way. You just need to remember that. Rest of the operations that I'm doing here, the multiple threads are involved in processing the elements. Okay, so where you can use this kind of scenario. For an example, if you can do this, imagine I have few elements here. Okay, let's say I have an element here, let's say 12, and then here I'm having something 55. Then I have another elements here in the list, let's say 33. Here I have another elements in the list, let's say 102 or something. Okay, there are a few elements over here. Let's say if I want to sort this list, okay, then how can I sort this list? If I want to print this to the console, I want to sort the list, and I want to print this to the console, then I might be using something like this. Let's say list of integer. I will open up the stream, and imagine I want to process all these elements parallelly. So I'm going to use dot parallel. I'm always using dot parallel, isn't it? Let's say I have the collection, and from the collection only, I can also use dot parallel stream directly instead of doing stream dot parallel. Okay, this is also the same thing. And after that, let's say I'm doing dot sort or dot sorted. I want to sort all the elements that I have inside the stream pipeline, and then I want to print it. Okay, and I want to print it like this. I'm gonna do I'm gonna take each number and I'm gonna print it. Maybe I can use the method reference over here, system.out println like this. Okay, and but for example, if it is the normal stream, what will happen? Obviously you will see everything sorted over here. Okay, 1 2 3 10 12 33 55 102. You can see that this is where I have messed up the numbers, so it should be sorted, and the way it is sorted, I think I'm pretty much happy with that. Okay, so with dot stream it works fine, but if it is dot parallel stream, okay, then what will happen? Then as I have told you, the sorter should be sorting the elements, but I'm using dot forEach, and here multiple threads will be involved processing all these elements. So once the elements are sorted, the forEach is not going to wait till the elements will be sorted. Whatever element sorted first, the forEach is going to grab it. Okay, if I'm going to run this, you can see the way it has been sorted. Okay, this is not what I have expected, right? Because I'm using dot sorted over here. So what I can do, I can use forEachOrdered over here in order to make sure while consuming the elements, I should be ordered. I should be wait till the elements are sorted by the other thread, and then I can grab it over here by using the forEachOrdered. And now you can see everything that you have is in order only, right? So be very careful while you are using the forEach and the forEachOrdered, because sometimes the forEach can be dangerous if you are using it with the parallel stream. I think it makes sense, right? Let's just go to the next thing. Okay, so I want to show you another important thing here. So I'm going to remove everything that I have here. Okay, and I'm going to remove all these imports as well. Okay, so I have just an array list. Okay, and this is some kind of concept that you have to understand whenever you are using the stream, the parallel stream basically. And this is not that you don't know about it. You must have complete awareness on this, but just I want to bring this thing to your attention so that you should be aware of it. Okay. All right. So I have a array list over here. What I want to do, let's say I have a for loop. Okay. And let's say I start this loop with I equal to 0, and I will have I less than equal to, let's say, 4. So it will run for 5 times, or I'll go for 1 and I'm going to say less than and equal to 5. Okay, this loop will run for 5 times, and what I will do, I will do I plus plus. And inside this loop, what I'm going to do, let's just say s out, and for 5 times, I'm going to say list of integers dot size. Okay, obviously the size will be constant. This will be an empty list. The size will be 0 for sure. If I'm going to run this, where is run Java option? Here it is, and it prints 5 times 0 0 0 0 0. Okay, I hope you understand. It's a list. I'm printing the size of the list for the 5 times. Okay, And also I want to print the content inside the list. So I'm going to say s out of list of integers. And obviously I haven't added anything to the list. So it will be every time it will be printing an empty list, then the size of the list, empty list, and then the size of the list. And it will do for 3 more times because we're printing it for 5 times here. Okay, I think it's clear. Now, I want to keep on adding some element to this array list. Okay, before I start adding elements to this array list, I will just show you a scenario. Maybe that's very important. Let me come in this. What scenario I'm going to be showing you? I'm going to be showing you a method called iterate. I'm not sure, like, if I have discussed about the iterate method previously. Let me tell you quickly what it is. Imagine I have the stream and then I have a method called iterate over here. I think I have told you guys about this method. In this method, it basically helps you to create an infinite stream or an infinite stream, the way you say it. What it takes a seed, the initial value, and an unary operator. I'll tell you what this unary operator means. The first thing, it takes a seed, the initial value. Let's say the initial value, I'm going to give it to 0. Okay, and then an unary operator. If you're going to go to the iterate method, you can see it takes the seed. This can be of any type, integer, string, blah, blah, blah. Here I have taken 0, so I'm just specifying an integer over here. And then inside the stream.class, I'll go over here one more time. And here, if you're going to see, it's going to take a unary operator. Okay, what this unary operator is basically a function. If you're going to go to the unary operator, you can see it extends to the function. Okay, the only difference is the unary operator, the type of input it's going to accept, is going to return you the same type of output. Okay, unlike function, the function basically takes any kind of input and returns any kind of output. Okay, so the T and R basically suppressed to only T in unary operator. So the unary operator basically have the same apply method as function. Okay, but whatever input it takes, like integer, string, or blah, 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 the output will be also of same type. If you're going to take integer here, this should be also integer. And I think you know about this. Let me go back to my iterate method. Okay, I'm taking integer over here. It takes a unary operator. So what I'm gonna do over here, whatever number I am taking over here, okay, I'm gonna do number plus 1. Okay, so basically I'm summing up. Okay, if I'm gonna take 0 here, this will be 0. So 0 plus 1 will be 1, right? So this will be 1 next time. And it will be keep on iterating. It will be 1 next time. So I'm going to take 1. So 1 plus 1 will be 2. Then I'm going to take 2 here. This will be replaced as 2. Then 2 plus 1 will be 3. Then it will be 3. 3 plus 1 will be 4. And it will be keep on iterating, and it will be keep on summing off the thing. Okay. If I'm going to do this, okay, let's just see what is going to happen. Basically, nothing is going to happen. Okay. If I'm going to clear this, I'm going to run this, nothing is going to happen because I'm not consuming this thing. So streams are lazy. I'm going to make sure I'll have a forEach. I'll take the number, whatever it is generating, and I'll print the number over here. Okay, and that will work. If I'm going to run this, okay, it'll be keep on, summing off and keep on, adding off the number. And this is going to give me an infinite stream. Let me kill this. Okay, let's say here I want to use a condition. Okay, let's say I don't want to keep on generating the number. Instead, the iterate function has an overloaded method. So I'm going to come to the next one. See, it takes a seed, it takes a unary operator, and also it takes some kind of a predicate, what it says has next. So using this, you can have a kind of statement which will return you true or false. And with that, the iterate method will work, just like your for each loop. Sorry, not the enhanced for loop, the traditional for loop I'm referring to, just like this. Okay, same thing, same condition check you can have over here, the way you are doing the condition check over here, right? So it takes 2 arguments, the seed, and this is how the incrementation has happened for us, like this. We have done that thing over here, and this is the initial value like this. And here I can have a condition check like this. Okay, so what I'm gonna say, whatever number that I'm having over here. So I told you I'm gonna take that number and I'm gonna increment to 1 in each iteration, and that's how it goes, right? So I'll have a comma over here and I'll have a predicate. Okay, the predicate will be, I'm gonna take this number, okay, whatever number that is, and I'm gonna check if the number is less than and equal to 20, for an example, or 10, let's say. Okay, so every time it will increment to 1, before that it's going to have a check if that seed is exceeding 10 or not. Okay, so as long as it is less than or equal to 10, this iteration will go on, just like your for each. Okay, if you're going to run this, see, I have restricted this infinite iterate to 10 elements. Okay, just by giving this predicate over here. So why I'm telling you about the iterate function over here, because I want to use it. So let me remove this. Okay, let's just come to my example. Here I have created an array list. Okay, and what I'm doing, I'm having a for loop, and I'm printing the list of integers, that content of the list, and I'm printing the size of the list. But before doing that, before printing the size of the list and the content of the list, I want to add some element to the list. Okay, so what I'm going to do, I'm going to take the iterate method to do that. Okay, so I'm going to do stream.iterate. What is that method? Iterate, right? Iterate method is going to take a seed. The seed will be 0, let's say, the initial value. Then it takes an unary operator. Let's say I'm going to take the number and I'm going to say number plus 1. Okay, so every time the number will be incremented by 1. So I'll be keep on getting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and it'll go infinite. So what I'm going to do, I'm going to restrict it by using a has next. Okay, so has next means a predicate. Okay, I'm going to check if the number is less than and equal to 20, let's say. I want to generate only this many number. Okay, so this iterate method will be keep on generating numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9. I told you that already. And I'll have a terminal operation called forEach. I'm going to take each number that it is generating. Okay, and let's say it's going to generate number 1. I'm going to take that number, I'm going to consume that number, and I'm going to add it to this list. So how to add an element to the list? I'm going to say list of integers dot add, and I'm going to take that number and put it over here. Just the way you print it, I'm going to add it to the console. I'm going to add it to the list. Okay, so now what I have a kind of internal for loop. Okay, which takes 20 elements and add it to this list of integers that I have over here. Okay, so if I'm going to run this, what is going to happen? Okay, so you get a list first. 20 elements has been added. Okay, 0 to 20. So started with 0, goes up to let's say, instead of saying less than or equal to 20, maybe what I can do, I can start it from 1. So I'll have 20 elements. Okay, so let me clear this once. Don't go mad by looking into the console. I'll explain. Okay, look at the first 1 to 20. The 20 elements has been added. So here I'm printing the list, and the size of the list is 20 because we have 20 elements inside this list. Okay, so next time what will happen? Again, the for loop will be continued. Second time again, 20 elements will be added. The integer the list, whenever we're printing the integer list, it will be showing me 20 elements, but this time it is showing 40 elements. So previously we have this 20 elements added in this time. Okay, then again it is adding 20 more elements, the size is 40. So what I want to do, before I iterate, every time I iterate, I'll clear this list. I'm going to say list of integers dot clear. Okay, I'm going to clear this list. I'm going to run this right now. You can see 5 times I'm running this for loop and adding 20 elements. Okay, you can see 20 elements, the size of the list is 20. 20 elements, size of the list is 20. And for all the 5 times, I'm getting consistent result, right? Now let's just have some fun. Okay, and I have a question for you. Imagine what I'm going to do. Okay, so here I have the iterate method, right? Now imagine the pipeline that I have created. I want to use dot parallel over here. Now what will happen? So let's say I have 20 or 30 or 100 elements that I'm trying to add to this list, right? So everything will be processed parallelly, right? This forEach method is going to do what? I told you the forEach method is going to consume the element and going to add it to the list. Okay, so multiple threads will be involved adding all my 20 elements to this list, isn't it? Okay, so things can happen quicker over here because it's not only one thread which is adding all my elements to this list. It's like all my CPU core that I have, all these cores that are involved in adding the elements to this array list. Okay, so if I'm going to run this, what do you expect over here? Well, you might say, okay, so every time I'm adding 20 elements over here, the 20 elements will be added to this list. So here you'll get 20 elements, but they may not be in sequential order like this because we're using forEach. So insertion order might not be preserved. So you will get 20, but maybe the 5 will be added first, the 4 will be added second, the 1 will be added last. That is absolutely possible because with the forEach, the insertion order is not guaranteed, right? But the size, whenever we are going to print the size, okay, so in every iteration, this will ensure that the 20 elements will be added, right? So we're expecting the size will be 20 every time. Let's just check. Let's just run this and look at the output. Okay, let me clear everything. Okay, run this again and look at the output. Okay, in the first iteration, whenever we're using forEach, why I've iterated it for 5 times? Because just to showcase different scenario for you. If it is 1 time, let's say if I'm going to say I less than equal to 1, then you'll get only 1 output, right? Let's just run this. Okay, when I get only 1 output, you can see whatever I said, the forEach ran, and I can see you got 20 elements added to the list. But yeah, it's random, right? So you won't be observe the problem here. But if I'm going to do the same thing for multiple times, okay, just to showcase you a scenario, let's say I'm going to do it for 5 times. Okay, so let's say run this. Okay, now look at this. In the first iteration, 20 elements got added. But in the second iteration, even though I'm trying to add 20 elements, okay, only 18 got added. So we lost 2 elements. Do you think it's a problem? Whenever you are working with a production application, you are trying to add elements to your array list, and sometimes you see, okay, some elements goes missing, right? You can see here in this iteration, things are fine. 20 elements got added. We're trying to add 20 elements, 20 gets added. But here, 19 get added. In this iteration, again, 20 got added, right? So the thing is, if I'm going to run multiple times, you can see the results are inconsistent, right? Here in this case, couple of times, 18 elements got added. So what is the problem? So you remember this. Whenever you're working with array list kind of data structure, the array list is not thread safe by default. You understand the thread safety, right? Thread safety means here, whenever we're using the parallel stream, multiple threads basically involved in processing my elements, and they all are working parallelly over this array list object, and they are adding elements to different indexes of my array list, isn't it? But the array list is not by default made for multiple threads to work over it. The array list is not made for that. This is not thread stuff. You remember your theoretical understanding? Array list is not thread stuff. Vector is thread stuff. If you're going to use vector instead, okay, if you're going to use vector right over here, okay, run this, okay, in each iteration you got 20. Okay, we're going to run multiple times, okay, in every time you'll get 20 elements added, right, because vectors are thread stuff. But when array lists are not meant to work with multiple threads. You need to make sure this list is synchronized. Otherwise, you'll get inconsistent result. What basically happens is, let's say there are 2 threads who are basically adding elements to this array list, where one thread, let's say all threads are keep on adding different elements to the array list buckets. It is absolutely possible that whenever one thread is adding one element to the array list, in the same, so it is trying to add one element to the array list bucket. Let's say 10th bucket, it is adding one element. But in the same time, the other thread is also see the 10th bucket is vacant. So it can also add the element to there. So now both of this thread is adding one element, the respective element, to the same 10th bucket. So it is the absolute probability that one thread writes an element to a particular index of an array list, and then another thread basically overrides that element inside the same 10th index, right? So we lost one element over there. Like that, the overriding can happen. If I am writing an element to one index of the array list, another thread can also see in the same time that, okay, this index is vacant, so let me also put the data inside that same index. And we cannot able to protect this kind of situation whenever we are working with multiple threads over array list. So it's not thread stack. So one good option is, whenever you are creating array list, you can use concurrent array list or copy on write array list, or you can just use the collections.synchronized list. Okay, this will ensure that the array list is synchronized and then locking is involved. And if you're gonna run this, now you'll get the consistent result. Okay, so you can see in each where is it? Run this. Okay, I'm not getting consistent result because the synchronized list is basically going to return you a new list of integers. So I'm going to say I can assign this to, okay, synchronized list or something. Okay, it's going to give you a list back. Okay, let me import this, and now you can use this sync list to add your elements. Right now, the sync list is basically taking your array list and making it a synchronized list. So if I'm going to run this right now, okay, so I can see it's all 20 elements. So doesn't matter how many times you're going to be running this, you're going to be getting the consistent result over here, right? So be very careful whenever you're using the parallel stream kind of thing over here, over a kind of array list. Okay, I think this concept is clear. Just keep that in mind. Let's just switch to the next concept. But just for your experiment, you do it, because I don't want to get into much into the thread and how it works, because this is a separate topic. But in your own time, you just check this scenario. Let's say if I'm going to use the same array list, okay, and if I'm going to do this, then obviously I'm going to get this inconsistent result over here, because the array lists are not thread safe. But what will happen if I'm going to use forEachOrdered? So do you think I'm going to be getting consistent result each time? If no, why? If yes, why? Okay. You just try this example and let me know in the comment. Okay. Mention the timestamp and let me know in the comments. Okay. But I will not waste my time here getting into the threads and other stuff. Let me show you some more use cases which will be helpful for learning the parallel stream. Basically, I wanted to discuss about the fork join framework, the way it works. It's not a good place to discuss about it. This is a wrong playlist to discuss about it. Maybe we can have some more videos, but let's just go to the next scenario and let me just give you some more concept on the parallel stream. Okay, but you just try out this example by your own. All right then, so let's just go to the next experiment that we're going to be doing on our parallel stream topic. So I think you are understanding the way the parallel stream basically works, but let's just check some advantages of using parallel stream and the way it works and where it is best suitable. Okay, imagine we are trying to add a few number. We're trying to find the summation of few numbers. Okay, so let's say I'm going to be forming some number. Maybe I'm going to use a long stream. Like you have int stream, you also have long stream to handle long type of values, right? I told you about the boxing and auto boxing and auto unboxing in Stream API in the last video. So I hope that you are aware about it. If not, it's pretty simple. Look at this. So long stream is a specialized class to deal with long values. And I can use something called range closed to generate some random numbers, okay? Random long values. Let's say I'm going to be starting with the number, let's say 0. And I will go till 10. So I'll get values between 0 to 10. And, I can just do for each and I can simply print it out just to make sure like we are getting the right values. So I'll be able to print the values from 0 to 10 in this case. Okay, so 0, it will be inclusive, and 10, it is also inclusive. So we'll get values from 0 to 10. Okay, which is good. Let's say right now I want to do what? I want to sum all these values. Okay, I want to find a sum of 0 to 10. Then how can I do that? Well, there are so many different approaches, but one good thing using long stream or any kind of classes that we have in Stream API like this, like for int, we have int stream, long, we have long stream, right? So for one of the specialty of this classes, if you're going to compare it to your normal stream API, this API long stream have some specialized method like sum. Okay, if you want to find a summation of all these numbers, let's say. Okay, so if I'm going to do this, then I'll be able to find the summation of everything. It's going to give you a long back, so I can have the return type over here. I can say long sum, and there you go, the value of sum. And let me just take it to one line, something like this, and I'll be printing as out of sum. Okay, so if I'm gonna print this, I'll be finding the value over here, which is 55. Okay, so this is like a sequential stream. Okay, so same way we can do this for the parallel stream. Okay, so if I'm going to say sum1, and I will just say dot parallel. Okay, And this is how I'm converting this long stream to a parallel stream. And then I'm just calling the sum method. Right now, all these numbers that we have between 0 to 10, let's say 0, 1, 2 will be processed by thread 1, then 3, 4, 5 will be processed by another thread of my CPU core, then rest of the numbers might be processed by another thread of my CPU core. So this line will be executed faster than this sequential stream, okay? So basically, if I'm gonna run this, okay, I'm also getting 55 over here for my sum one. Let me just replace this value over here. If I'm gonna do this, the value of both of these things are same, but this execute faster than this sequential stream. Okay, to prove you that, let's just have the time over here. So start time is equal to system.current time in millis, and let's say I'll just check how faster it is. Let's say time taken to sum all the elements. Okay, that will be the end time. Let's say I will again log my time here, then minus the start time. Okay, so I'll log the time over here. I will also log the time over here. I'm going to say start time 1, and I'll again print this over here. Okay, I'm going to say start time 1, and this is for the parallel stream. So I'm going to say for parallel, this is this. And if I don't do anything over here, this is by default a sequential stream, or you can just write dot sequential, but you know that there is no sense to write this thing, but let's just write this if you are interested, because you know what the sequential method or the intermediate operation does. It's basically convert your pipeline to a sequential stream. Okay, so let's just run this. Okay, now we can see the time taken for the sequential one is 6 seconds, the parallel one is 2 seconds. Well, sometime you might see some differences, and you might freak out if you're gonna see that the sequential is basically taking less time than the parallel. There might be some scenario. Let me just check that if I can get this. The parallel is taking 1 millisecond. Okay, my system is then too fast. Okay, but there might be scenario. Okay, let me just execute it for some time. Let me just see if I can stuck with that kind of scenario here. Okay, if I will take only, let's say, two numbers over here. Okay, it takes 5 seconds, it takes 1 second. Okay, for every situation, right now I'm getting my parallel stream is too fast than my sequential stream. But if you're gonna see some different results, like your sequential stream basically takes lesser time than the parallel stream, then don't freak out, because just like if you go to gym and then you do workout a little, like do some warm up a little before your workout, just like that, your system can do a little bit of warm up before getting into the real action. But do remember one thing, that the parallel stream basically comes handy whenever you're processing a large set of data. Okay, for an example, if you are processing, let's say 1 million or 1 billion data over here. Okay, let's say this many data I want to process. Okay, in that time only, the parallel stream will be really handy whenever you're processing a large set of data. Now you can see some significant time difference. This one takes 327 milliseconds, but this one takes just 52 52 millisecond over here. Okay, and you can see the result as same. So the parallel stream can be much faster than the sequential stream whenever you are basically processing a large set of data. But you may not need the parallel stream whenever you are doing a smaller task that might also cause significantly more time than the sequential stream even to process data if you're processing a smaller set of data, because it also take resources to create threads and do certain stuff, because behind the scene the parallel stream works with the fork and join framework. The fork and join framework basically have a kind of thread pool and some task creation going on, which basically does the task for you behind the scene. So I think you get it when basically you need to use the parallel stream. Okay, so this is one kind of example. So basically the way this thing works, I just want to show you this slide. Okay, see, in the sequential stream, the way it works, there is only one thread. Let's say the main thread is available, and let's say 1 2 3 4 5 6, you want to find a sum of this. Then first 1 and 2 will be summing it off, it will be 3. Rest of the number will be like this. Then 3 and 3, let's say it is 6. Then rest of the number will be like this. Then let's say 6 and 4 is 10. Then rest of the number is like this. Then 10 and 5 is 15. Then rest of the number is like this. Then 15 and 6 is 21. And you can see then you are getting your result, which is 21, which is the summation of everything. But the same thing, if you're going to do it with your parallel stream, it looks something like this. You have a task, then you are actually having, let's say, 2 threads which will work parallelly. So you are splitting these numbers in chunks. Let's say 1 2 3 has been taken care by thread 1, 4 5 6 has been taken care by thread 2. So it's a divide and conquer rule. So first of all, we have divided the task, then you are basically summing it up. Let's say 1 and 2, if you're going to sum it off, it's going to be 3, and the 3 comes here. Then 3 and 3, if you're going to sum it off, it's going to be 6. Like that, 4 and 5, if you're going to sum it off, it's going to be 9. Then 6 comes over here. Then 9 and 6, if you're going to sum it off, it will be 15. At last, you're going to sum off 6 and 15. Once this thread is over, this thread task is over, you're going to be merging the data. You're going to be summing it off. Then 6 and 15, if you're going to sum it off, it will be 21. So that's going to be the final result. Okay, so this is how basically your parallel stream you can leverage your threads, and you can use it up to the fullest to process all your data. Okay, so apart from this sum, okay, you can also do the same thing. You can also basically process the same thing. Instead of using the sum, you can also use the map reduce method or the reduce method in order to reduce a large set of value to, let's say, to one value. Okay, I think I have spoke about the reduce method in the last video, but let me tell you a little bit. For an example, let's say I have 10 elements over here. Okay, forget about this thing. Just have a look at this. So maybe I'm going to take it down so that you're going to be seeing only this. Let's say I don't need sequential. It's by default sequential. And here, let's say I'm going to have the reduce method instead. Instead of sum, I can also use the reduce. And reduce is another beautiful method which works best with the parallel stream scenario. If you're going to use reduce, it will take 2 things. First thing will be the identity. Identity will be the initial value. Let's say I'm going to start it with 0. Okay. And let's say I'm going to be adding off 1 to 10 numbers. Okay. Let's say I'm going to starting with 0. Then the second value will be a binary operator. Okay. And the binary operator, you understand, is basically takes couple of things and it's going to return you another thing. Okay. So basically, if I'm going to close this, so what I'm going to say over here, I'm going to take 0 as the initial value, and then I'm going to take two things. Let's say it's gonna take A and B, okay, and then you can actually sum it off. Okay, you can just do or maybe I can just do A plus B, okay, something like this. Then 0 will be your A, then B will be the first value over here, 1, then this will be 0 plus 1 will be 1. This will be 1 right now, so A will be 1, B will be the second value, will be 2, then 1 plus 2 will be 3. Okay, so this will be 3, and this continues, right? So if I'm going to do the same thing, I can also find the result. So let me just test it with the parallel stream way as well. So I'm going to be, instead of saying sum, I'm going to use the reduce over here, okay, to reduce the value to one single value, and the single value will be sum. Okay, so there you go. Let's just test this approach if that works with the parallel and with the sequential stream. If I'm going to run this, okay, let me have 1 to 10 here. Also I'm going to say 1 to 10. Okay, so if I'm going to run this, I can see the results are same. By the way, for 1 to 10 the sum will be 55, but the time taken for both of this approach is this. Okay, so it works in the same way, and I just wanted to show you this reduced way of doing the sum. And also, if you want to do the sum, if you don't want to do it by yourself like this, you can also use the long has a static method called sum. You can use this sum directly over here, something like this. Okay, this also works, or it can directly do something like this, long sum. If you understand method reference, you know how it works. It's the same whatever we have done previously, right? So this also will give you the same result. If I'm going to run this, okay, I'm going to get 55, and you can see the significant time difference between the parallel and the sequential stream on the console. Okay, the only important thing that you have to understand whenever you're using the reduce, you are just using an initial value over here. You can see it is 0. For reduce, you're using the initial value over here, which is 0, right? So one important thing that you have to understand here, okay, whenever you are talking about the fork and join framework, whatever used behind the scene is you have a task, okay, and recursively you are breaking down the task, right? Here the task has been split into a couple more. Imagine this will be handled by one thread and this will be handled by one thread, or you can go ahead and can break this task again. Let's say this will be handled by one thread, 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 right? So you can keep on breaking the task, you can keep on dividing the task, and then conquer the result. Okay, so maybe you can see this example. Let's say if you have 1, 2, 3, 4, 5, 6, 7, 8. Let's say this is the number you want to process parallelly. You can break this off. This 1, 2, 3, 4, 5, 6, 7, 8. And you can further, if you want to process like this, that's fine. Or you can further break this 1, 2, 3, 4 to 1, 2, then 3, 4. Let's say this will be handled by one thread. This will be handled by one thread. Then 5, 6, 7, 8 to, let's say 5, 6 will be handled by one thread. 7, 8 will be handled by one thread. And also you can sum it up after that. 1 plus 2 will be 3. 3 plus 4 will be 7. Then 7 plus 3 will be 10. 5 plus 6 will be 11, 7 plus 8 will be 15, then summation of this will be 26, and at last you can sum this up, 10 and 26, it will be 36, okay? If you want to use the normal sum method to achieve the summation of this thing. But if you're using the reduced method, the important thing that you have to understand here, the initial value, okay? So you can see right here, 1, 2, 3, 4, 5, 6, 7, 8 has been divided over here. Now, let's say all these things will be handled by separate thread. But the important thing here that for every thread, as you are processing it parallelly, the initial value will be 0. Okay, the initial value will be 0. The identity value will be 0 for the reduce method if you're using the reduce method, right? So if you're gonna use 0 over here, then 0 plus 1 plus 2 will be 3. 0 plus 3 0 plus 3 plus 4 will be 7. This will be 11. 0 plus 7 plus 8 will be 15. Okay, then this will be the value 10. This will be the value 26. Then you can sum it off. The total value will be 36. If you're going to process all these things, and imagine there are 4 threads involved processing all this data, then this is how the divide and conquer comes into the action. Okay, and the initial value should be 0. Okay, so don't think like, once you add it off, whatever the initial value will get, that will be the initial value for another thread. That doesn't work in that way. Okay, otherwise you'll get inconsistent result. Okay, so I was already into editing, but I see like I missed one very important thing, and we should be understanding this thing before we wrap up this parallel stream concept. Well, I have shown you a scenario like how thread safety can become a problematic thing if you ignore the thread safety part whenever dealing with different collections like ArrayList, which are not by default thread safe. So for an example, guys, let's say I have an ArrayList, okay, and let's say I have an ArrayList of integer, and let's say list of integers, okay, and I have a new ArrayList created, and I want to add some bunch of elements to this list. And so for that, I will take help of a iterator. Let's say I'm going to say stream dot iterate method, and I'll give the seed as 0. And in the second argument, I'll take the number, and I'm going to say number plus 1. Okay, so I have this iterate method which is going to keep incrementing numbers by 1. I'll be getting different number. And let's say I'm going to use forEach to consume all this number, and I'm going to say number, and I'm going to consume it, and I'm going to add it to this list. So I'm going to say list of integers dot add of that number. Okay, let's say I want to do that. So I'll be adding some numbers to this list of integer, but I think this will not even work. So if I'm going to run this, if I'm going to say run Java, I think I'll get into an exception. I think, see, this is still running right now. Is it still running? Yeah, so it's still running, and see, like, I get a out of memory exception for the Java heap space. If you understand this, can you let me know in the comments why did you get this exception? This iterate method will keep on generating elements, and in some point of time will go out of memory. Okay, because we cannot add infinite elements to an array list, right? So I think you understand that. Now let's just have some limit to this. So I'm going to say dot limit of 20, or let's say 20. So I'll be adding 20 elements to the list. Okay, and now everything is fine. Now I can print out this list of integers, and also I'm going to print the size of the list as well. Okay, so I'm going to say dot size, and there won't be any issues, so I'll be able to add 20 elements over here. But I want to do these things parallelly. So after this iterate, I'm going to say dot parallel to make sure these elements will be processed parallelly. But you can see in the first instance only, I have only 17 elements added, because I'm adding to a list which is an array list, which is not thread safe, And you can see in this instance 16 elements, in this instance 15 elements. Okay, so you can see that, how inconsistent I'm with this array list. Okay, so this is a reason, the array lists are not safe whenever you are talking about using it with the parallel string. I'm gonna give you one more approach to handle this kind of scenario. That will be with using a collect function. Okay, the collect function, like for each is a terminal operation. The for each is the collect is another terminal operation that we have, and you can use the collect operation to gather all the elements, right? Let's just see whether that works. So I'm going to say collect, and let's say I want to collect all these items to a list. Okay, so how can I do that? I can do this, Collector.toList. Sorry, collectors is a utility class, and I'm going to say toList, and this is going to internally create a list. And to be very specific, this is going to create an array list internally. And let's just see how that behaves. So this collect method is going to get you the list of integers. So now what I'm going to do, I'm going to say this is going to give me a list of integer list. And there you go. And let's say I'll comment this out, and I'm going to say this is going to get me a list. So basically all these elements will be collected using this function, and this toList method will make sure that it will put all these elements which has been collected into a list, and then will return me a list back. And basically this collect method will create internally, where it will be grab and add all the elements. That list will be an array list, by the way. Okay, internally it will create an array list and will give you that. Okay, so I'm going to be putting it over here. And also let me just try to check the size of this list. This is the collect method is going to return me. Let's just check the behavior over here. And you can see this is right now returning me 20. Let me just check for multiple times, and you can see for every scenario it returns me 20 elements. Let's just have a for loop just to check, if I'm gonna check it for around 10 or 20 times. If I'm gonna run this loop, I'm gonna say I equal to 0, I less than and equal to, let's say 10 times or 20 times, and I'll do I plus plus. I'll open up over here and I'll close it over here. Okay, so if I'm going to run it for 10 times, I'm pretty sure, see, for every iteration, okay, all my elements has been added, and it's 20 elements only. Okay, so this collect method can be used parallelly. You can use this collect with a parallel operation, you can use it, or you can use it with the normal sequential operation. But we are talking about the parallel operation over here. But the important thing that you have to notice over here, though I'm writing parallel here, looks like, the things are going smoothly. This parallel makes sure that it is going to split my elements that I have in the iterate method, and is going to process all those elements parallelly. Okay, and looks like the merging is happening to one final array list, and that list is given back to me. Okay, so basically somehow the thread safety is maintained over here by the collect method, because if the parallel stream is involved, means multiple threads will be involved. If multiple threads will be processing the elements, whatever the example that we have seen here, we might get inconsistent result, but it's giving me consistent result right now, because you haven't seen how this method has been implemented internally, what kind of list it is creating internally. But for now, I'm telling you that this is going to create an array list internally. So you might have an obvious question right now, why not if it is using array list internally, why not I'm getting inconsistent result like before? Let me explain you that a little bit, because this will be very important for your stream and the parallel stream foundation. Okay, instead of using toList here, can I use collectors, and I want to, let's say, I want to collect all this data that this iterate method is generating to a collection. So for that, I can also do that by myself. I have a method called toCollection, and the toCollection takes a supplier. It takes a supplier, as you can see. Okay, so I can supply a container or a list or to a collection where the elements will be stored, and the supplier takes nothing, okay, and returns something. Okay, so let's say I'm going to return a container here, or even though if I don't want to write return, that's fine. I can say what I want to return, a new array list. Okay, new array list of integer. So I think this line makes sense. The collector method is basically collecting all the data, will be collecting all the data to this array list. Okay, so I'm collecting all the data to a collection array list. Let's just see right now whether I'll be getting consistent result. Okay, and look at every iteration over here, I get consistent result only. I get 20 as a size. So how that works? Okay, before I tell you how that works, basically let me simplify this code. So it is returning a new array list. So directly I can say this statement, I can replace it array list, and I'll invoke the array list constructor like new. Okay, same line, I have replaced it with method reference, so it will look a little bit good to eyes and not confusing. Okay, in case you understand method reference, but I think you understand that this will basically return you a new array list. So the only important thing that you have to understand here is that previously with this array list, whenever we are adding all our elements, let's say whenever we're parallelly processing all the elements, all the elements are added to the same in the single array list that we have. Okay, so in that case, what happens if one element is getting added to some X index, the another thread might see that index is empty and tries to enter to the same index and ended up overriding a value, and that basically results in losing off an element and overriding a value, so that the list size was differing previously. But now what is happening, this collect method will do what? Here whenever you are processing the elements in parallel, imagine I'm generating number from 1 to, let's say the limit is 20. Let's say I'm generating elements, let's say from 1 to 20. So let's say what will happen here, imagine the thread 1 is handling from 1 to 5. Another thread is handling from 5 to 10. Another thread is handling elements from 10 to 15. Okay, and another thread is handling, let's say 15 to 20. Okay, let's say there are 4 threads involved processing these 20 items. Okay, from here like this. Okay, let's say 1 to 5 is taken care by this, 6 to 10 is taken care by this, and then 11 to 15 is taken care by another thread. 16 to 20, this 5 elements will be taken care by another thread. Okay, let's say T1 is taking care of this, and thread 2 is taking care of this, then thread 3 is taking care of this, and thread 4 is taking care of processing these many elements. Now whenever all these threads tries to gather the elements and trying to add it inside an array list, the most important thing that you have to understand, every thread will have access to this line of code, and every thread will create a new array list. That's the difference. Now this thread, for this thread, there will be a array list created, okay, where it will add 1, 2, 3, 4, 5. And for this thread, there will be an array list created where it will add, let's say, it will process these elements and add this 6, 7, 8, 9, 10, or in any order, right? Whatever ordering, I'm not concentrating on the ordering thing right now. Okay, and like that, here also one array list will be created. Here also one array list will be created. Okay, so for every thread, one container will be created, and that's what is getting done whenever you're using the collect method and whenever you're creating a new array list. Okay, and then once the array list has been created for every thread will be ended up adding their elements to the respective array list. And in the end, what will happen? There will be a combination will happen. And all these elements, let's say this has every element, this has every element, all the elements it has and all the elements it has, that they all has been combined and will be filled off inside one array list, like 1, 2, 3, 4, and like that it will go up to 20. Okay, so this is the thing which is happening behind the scene. Okay, and that's why we're not dealing with only one array list, we're dealing with many, and the things happen in this way. So if you want to run this, you are not seeing any, any inconsistent result. The size is always 20 here. So the same thing, if you're gonna change this thing, this is just for example, if you're gonna use Collectors.toList, the same thing happened behind the scene here. Okay, if you're going to use the collect method, if I can break this and I'll keep it here, okay, where I'm collecting all the elements, this toList method, the way it works internally, if I'm going to go into this, I told you the toList will create an array list behind the scene. If I go into this, so this, where is the toList implementation? Collector impl to collection. I don't need to collection. I just need to list. Okay, here is the toList method. Okay, and you can see here in the first parameter, a new list is getting created. Okay, the same thing that you have done before. The toList is internally creating a new list. Or what kind of list is that? Array list. And what it is giving? A list object. Okay, so that's what you can see. Okay, so that's why whenever you're using toList, internally it's create an array list and gives you back the array list over here as an implementation. So array list is the behind the scene implementation, and that's what the collect method creates. Okay, second thing that you have to understand, once it creates an array list, as I said, once is, let's say this thread will create an array list, this thread will create an array list. It will, let's say this thread is processing 5 elements from that parallel stream. Many elements are there. 5 elements, this one is processing. Then those 5 elements will be added. Okay, so that will be added. That adding operation, you are not doing it by yourself over here inside this collect method. Okay, so inside this collect method, whenever you are using this method internally, it is creating a new list and also adding all the elements. You see how it is doing that? See, it is basically creating a list over here and also adding all the elements over here. List : add means it is adding the elements, right? And then the third parameter, this is a combiner. Here is the combination is happening. It is saying left and right, both are list. This is left array list, this is the right array list. Imagine you have 2 core CPU where 2 threads are involved, for an example. So it is doing, imagine this is an array list, this is an array list. It is doing left dot add all, okay, of right. And it's taking this array list, putting it inside the add all method of left array list. Okay, so left, this is array list dot add all of, it is giving the entire array list and returning the left array list. So you get the entire, so we have 2 array lists. Now we are adding all the elements of this array list to this array list and returning the entire array list that we have and returning it back. Okay, and that's how you are getting all these elements as a combination, even though they have been processed parallelly. Okay, So you can also do that by yourself if you want to try that. For an example, here you can see you have this collect method. Okay, you have a collect method which takes a collector, and also you have a overloaded collect method, I feel. So this is one collect method. This is another collect method. See, you can also use this collect method directly. First, it takes a supplier. Second, it takes an accumulator. Third, it takes a combiner. Supplier will be the container where the collect method will create a container, okay, to keep the items. The accumulator, where we can do some operation to add the elements to the container that we are creating, okay. And then here we are taking a combiner. Combiner means we have 2 or 3 containers, let's say, created. Let's say 3 threads are operated and creating 3 different containers. Then this combiner will basically combine all those 3 containers and give you the final result. And for that, we're using a by consumer. Okay, so you can try implementing this method as well. Let me just do that for you, and you can also read this documentation. You can see supplier, a function that creates a new mutable result for the container. For parallel execution, this may be called multiple times and must return a fresh value each time. Okay, if you're using it in the parallel stream scenario, this will create new container. If 2 or 3 or 4 or 5 threads are operating, then maybe 5 containers it will create. A fresh container will be returned. For supplier, where the container will be keep on having their items. Okay, then an accumulator, a function that must fold an element into the result, into a result container. So if you have a container, the accumulator job is it is going to be adding those elements to the container. And then the combiner, here you can see functions that accept 2 partial results containers and merge them, which must be compatible with the accumulator function. Okay, the combiner function must fold the elements from second result container into the first result container. Okay, in simple line, maybe I will show you an example. Let's say instead of using this collector, which basically this here the toList method internally doing the same thing. This is the container, this is the accumulator where it is adding all the elements, and this is the combiner, right? So let's say it is taking some constructor, passing all those things, and here it is accepting those data and doing something. Let's say I'm gonna do that by myself. Instead of using this collect method, I'm gonna use the 3 parameter collect method. Okay, first thing will be a supplier. Okay, supplier takes nothing and then it returns something. Let's say here I'm collecting all my 20 elements. Okay, here I'm collecting all my 20 elements, limit is 20. Then I'm gonna store them inside a array list, for an example. So here I can say new array list. Okay, so this is going to be my supplier. Okay, I have 3 more value here. Okay, I'll pass in all these values, no worries. So this is going to be my past parameter, or I can simply say array list : new, which means that any thread which is operating over it, it will create a new container. Okay, second thing, accumulator. That means let's say we have this array list created. Now we need to keep on adding the elements to this list for, let's say, for each thread. Okay, then how that can be done, you don't have to think about in thread way. Think very normally. Okay, you are creating an array list. Okay, in this array list you will be adding the elements. So how will be adding the elements? For that you need to take an accumulator. Accumulator is of what type? Is of a by consumer type. By consumer means what? By consumer means it can take 2 parameter, okay, and can return nothing. Okay, it takes 2 parameter. Okay, and that means 1 parameter we can take as an input. Second parameter we can take as a value, right? Whatever we want to add. Okay, in our case, let's say here the first parameter will be the array list that we will be dealing with. Here we are creating an array list, right? And then the second parameter will be the value, okay, that we'll be getting from this iterate function. Let's say 1 or 2 or 3, the value that we want to add. Okay, And then what I can do, I can just do this list dot. Okay, I have taken list over here. So I think I cannot reuse the value. And I can say my list here. Okay. And I can say my list. This is the instance of array list that we have created. And then we can say dot add. And we can, the second parameter, we can add it over here. Okay. And how we can replace this statement? We can just say simply every elements that we are dealing with, just add it. So I can directly say array list add. Okay. So every elements which will be coming, let's say 0 will become in the add method, it will be automatically passed. 1 is coming inside the add method, it will be automatically passed. Okay. So this is your accumulator. Okay. Which will add the value to this container. Okay. And the third thing is very important for the parallel processing. The third thing is the combiner. Here, what we want to do, we want to combine the result. Okay. So right now, imagine we have two array lists. Let's say left array list and a right array list. Let's say think about a scenario where we have two lists. Okay. And in each time, what we want to do, we want to take this and we want to return what? Left. Okay. Dot add all. Okay. And it takes a collection. Right. Okay. And this is what we want to return. If I don't want to return anything, if I don't want to write anything, then automatically whatever, this is something that I want to return. Right. So that's it. Okay. So now if I'm going to run this, okay, I am getting the same result as you can see. Right. So think about this collect method and understand how the collect method works internally. Okay. Because the same thing will happen whenever you are doing this Collectors.toList. This question is being asked by the interviewer and can be in any interview that, okay, how the collect method basically works and how, even though the toList method, you can see the toList method is returning a list back. And even though if you're going to go to the toList method, you can see the internally it is creating an array list, then how you are able to get consistent data whenever you are dealing with the parallel stream, because the array list is not supposed to be thread safe. So how you are handling that? The catch over there is that the toList method have array list colon new, but this many container will be created. Consider the fact that if 2 threads or 3 threads or 4 threads are working over it, then 4 new container, 4 new array list will be created. Okay. And these elements will be added to the respective array list. And in the end, the things will be joined or will be combined over here. Okay. Now let's come back to the question that I have asked you in the beginning. Okay, let me use this same example only that I have taken over here. Guys, see, here I'm doing filtered, blah, blah, blah over here. Okay, I asked you a question. Some people ask this. Instead of filter, I can also do like, takeWhile method over here. Okay, in order to process the data, right? I can also remove the parallel over here. If I'm going to do the takeWhile, then what will happen? Now the logic, whenever I'll be keep on processing the data, whenever the logic fails, okay, whenever this filtration fails, there only it will cut off the pipeline and will immediately throw you the result. It will not process the other data that I have after the condition fails. For an example, I think it's a sequential stream right now. So let's say right now Jareen has S39, S32. This is S22, right? Jatinar has S22. So right now when Jatin will be processed, now this condition will be failed, right? Because that is not greater than 25. So after the first couple of elements only, I think the takeWhile will be short circuiting the stream and nothing will be printed further, okay? Because it's not a filter method. Filter will check every element that you have in the stream, but the takeWhile will only check till the condition fails. It will find the largest prefix. Okay, so if I'm going to run this, okay, I think only a couple of student data that I have over here, which is Jareen and Avilash. Okay, over here is making sense. Right now, some people ask questions, okay, why the takeWhile is a stateful operation? Okay, it's a stateful intermediate operation. So why do you think like it has to remember the state? Why do you think like, every student which is getting processed through this takeWhile, why do you think the takeWhile has to remember all the student that it is processing? It is not required, because once the condition fails, it can terminate, right? What's the logic to remembering the student or buffering the data that it is processing and storing it inside it? Okay, because it's a stateful intermediate operation. This question might look correct whenever you are talking about sequential point of view, but think about in a parallel stream point of view, because whenever you have this kind of question, you think logically in both the scenario, right? For an example, if I'm going to activate the parallel stream, think like what will happen. Right now I have many students, right? I have all these students. Every student will be processed right now by different thread, right? So different thread will be acting upon this takeWhile. You want to see, you want to have that again. I'm going to print the student, and I want to also print like by whom it is getting processed, right? The thread processing student by thread, and the thread name is whatever. Let's say current thread dot get name. Okay, that's it. Okay, so now we're going to be seeing like the takeWhile method whenever I'll be processing the student over here. If I'm going to run this, you see the log, right? Okay, the data that we get is same only, Avilas P and Jareen. That's the data that we got. This is how we have to print the data, right? The output is same, but you see like every student that I have, look at the takeWhile method log that I have over here. Every student like Kiran has been processed by the main thread. Jareen has been processed by the worker 9 thread. Vishal has been processed by the worker 4 thread. Priya has been processed by the worker 5 thread, right? So the takeWhile method, whenever it is going to apply the condition, it has to remember whether the student is valid or not, right? So it needs to store the data, because the takeWhile method can also be used in a parallel stream, right? So it has to buffer the data inside it, whether if the condition match, so that it can give you the final result like this, right? So whenever you have question like why it is stateful, if somebody is asking why it is stateful, it is not required to remember, then think about the parallel stream point of view as well, right? So I know whenever we are learning, we have a crazy mind and we think differently. Okay, we think questions like anything. Okay, so keep that thing in mind. Okay, that's pretty much it right now. That's the answer for the question that I have asked you before we started the parallel stream. And I think that's pretty much it right now. That's it for now. That's pretty much it for this session. There are a few more things remaining for the parallel stream. Maybe we can talk about, there are some terminal operation I'm yet to discuss, like find any function which are best suitable for the parallel stream operations, because they are short circuiting in nature. So I will talk about it, how it works with the parallel stream. Maybe I'm going to create one more video. So stay tuned for that. And also I'm going to show you one more video. If you are following this particular series, I also want you to see that particular video as well. Okay, so go to my channel and you will find a playlist called Reactive Java. And for this, the Stream API is the prerequisite. So if you have completed Stream API, you can also learn this. Okay, the first video, this one. Go over here and learn this chapter, how Java Stream works. Okay, so just 20.51 part. I have discussed about 2 questions, and if you have reached to this level, you will be able to understand how Java Stream works. Okay, so watch this part and you will get some really good scenarios and use cases. So have a look on that over here. Okay, so I'll be back with another video, but now this is it. And I'll see you guys in another video, maybe on Stream API. There are a few more things remaining. Maybe I'll publish one or two more videos on this. But till then, practice this and let me know if everything makes sense to you. And how's this series going? If it is going all good for you, let me know in the comments, and let me know your thoughts as well. And consider subscribing to the channel if you want to stay updated with the further contents. And I'll see you guys in another video. That's it for now. Thank you very much and have a good day. Bye-bye.